The particle p is moving along a straight line that passes through a fixed point 0. The displacement s meters of p from 0 at time t seconds is given by s is 3t cubed minus 15t squared plus 25t plus 8 for t being between 0 and 3. Find the time when the velocity is 0 and hence determine whether the particle changes direction and describe the motion of the particle for t being between 0 and 3. Okay, so we've got s is 3t cubed minus 15t squared plus 25t plus 8. In order to find velocity, we need to differentiate this, so we're going to get 9t squared, v is 9t squared, 2 times minus 15, which is minus 30t, plus 25, and then when you differentiate 8, you get nothing. We want to find where the velocity is equal to 0, so we'll put 9t squared minus 30t plus 25 is equal to 0. Now we try to solve this. So 9 times 25, which we call the product, is equal to 225, and the sum is the middle term minus 30. We then want two numbers. When we multiply them together, we get 225, and we add the same two numbers, we get minus 30. With a bit of trial and improvement, you will come up with minus 15 and minus 15. So we've got what I think here is a repeated root. So writing this down, we've got 9t squared minus 15t minus 15t. So splitting up minus 30t into that, plus 25 is equal to 0. We put these two together, and we take out the highest common factor, which is 3t, and then in here we're going to get 3t minus 5. Bring down the sign, and then group these two together. So the highest common factor here is 5, and in brackets here we're going to get 3t minus 5. Make sure you change the sign because you put a bracket in. We've got a minus sign here. Notice minus 5 times minus 5 gets back to 25. So here and here you have the same thing, which will always happen when you do this for quadratics. So we get 3t minus 5 times 3t minus 5, which means we've got 3t minus 5 squared. Now this is what's known as a repeated root, so there's only going to be one value of t where the velocity is equal to 0, which will be when 3t minus 5 is equal to 0, which gives you t is 5 over 3 seconds. It says hence determine whether the particle changes direction. So if we sketch the velocity, so we sketch this function, it's a quadratic. So we draw a set of axes. We know that it crosses touches the t-axis at 5 over 3, which is there. And we know that it will cut the vertical axis at 25, so we'll mark it there. It's only a sketch. So this is a happy face. It only touches the axis once, so therefore it's not going to cross the t-axis, because we only have one repeated root. So let's just look at that again. So the velocity graph does not cut the t-axis, therefore the particle does not change direction. Okay, so we've got to sort of now describe the motion. So let's write down the equations of motion. That's displacement, velocity, and if you want to get acceleration, we differentiate this again. We're going to get 18t minus 30. So basically the particle starts at 8 meters from 0 with an initial velocity of 25 meters per second. The initial acceleration is going to be minus 30. The particle slows down and the velocity is momentarily 0 meters per second. But the particle does not change direction, because if it changes direction, the curve will go below the axis, the velocity graph will go below the axis, and then speeds up. At t is equal to 5 over 3, the acceleration will change from being positive to negative. Now we can look at this using this Geogebra Applet. So here we got our particle p 8 meters from 0 at the beginning. If we press the timer here, so we press start, because it goes up, slows down, and then carries on in the same direction. So in no circumstances does this actually change direction. We can click here to get the displacement graph, and do the animation again, you can see here, and then at this point here it's going to slow down and then it's going to carry on. Okay, if we put the velocity graph, we can see here at the repeated root, this is where momentarily the particle is equal to 0. And here we can see the acceleration starting off being negative. Let's see if I can move it up slightly. Move it up slightly, there you go. So starting at -30 and then becoming less and less negative, having the effect of slowing the particle down, and here it changes and then increases in the positive direction, therefore the particle will speed up. But the important thing is about this, that the particle does not change direction. So the Geogebra app I will put in the notes of the video. I hope you've understood, and I thank you very much for watching.